Hey, what's up? It's Jake, and now I'm going to go over the while loop, and I'm going to show you how to do this with a neat little binary trick. So, we already went through all the different things you can do with a for loop. It's very useful, but the while loop is also incredibly useful when you need to loop over a sequence or a collection as well. But you have to remember that uh, sometimes using a for loop makes more sense because when you have to add logic or conditions inside of a while loop, we call that boilerplate, and you're just recreating what is essentially a for loop, and maybe you should just use a for loop instead of a while loop. But we'll get into that. Um, the the key thing to keep in mind when you're deciding which loop construct to use is that the for loop is best suited for cases where you need to iterate over elements of some container or iterable object. And in other cases, you need to loop over something until some condition is satisfied, like until something is false or until something is true, or loop through something 39 times and you're going to loop through it until you get to 39. That kind of stuff. So it's similar. They both loop, and they both loop through the body of instructions and execute them. But like I said, the while loop doesn't loop over a sequence, right? So it can, but you don't want to avoid the boilerplate problem. So we're just going to use a while loop to iterate over something until a condition is satisfied. So let's look at this commented thing I have here. So I'm going to try to return the binary representation of an integer. So what's the binary form of 6, for example? Well, you could divide by 2 and you get a remainder of 0, but you have 3 left. And then you divide 3 by 2 and you get 1 and you have a remainder left. And then you divide 1 by 2 and get 0, and then you have a remainder of 0. We've reached the end of the numbers, and the list of remainders is 0, 1, 1. And if you reverse that, 110 is actually the binary representation of the number 6, the decimal number 6. So it's kind of a neat little trick. I never thought about it that way, but we're going to write some code to try to calculate this and see what happens. So let's pick a number. It could be anything. I'm going to pick 39. No, let's stay consistent. 42. I was going to do 39 because it's my age, but all right, so let's say that we have a list called remainders, and we're just going to create an empty list. And then I'm going to write a while loop, just like I did the for loop, but this one I'm going to say while n is greater than 0, okay, in this case right now n is 42, what are we going to do? So we're going to go remainder, we're going to make a remainder, singular, and we're going to say n modulo 2, okay? So this is going to give you remainder of division by 2. And then you're going to go remainders dot append whatever the remainder is. And then that will add that to the list. And then we're going to n divide equal 2, which is we are going to divide n by 2 at the end. So that's essentially how we're going to do this. And then at the end, what we'll do is we're going to take remainders, dot, and then here's a new one you're going to learn called reverse, and you can reverse the sequence. So if you have a sequence that goes 1, 2, 3, 4, 5, you could take sequence, whatever the name is, dot reverse, and it will say 5, 4, 3, 2, 1. And then we're just going to print after that remainders. Okay, so let's see what happens. So if I run this script, I get 1, 0, 1, 0, 1, 0. And if I change this to 7 or 6, let's see if it returns 1, 1, 0, I get 1, 1, 0. So that is how that works, but let me explain this a little bit of what's going on specifically in the while loop. So we put n is greater than 0, while n is greater than 0. So it's the condition to keep looping. So the code matches the algorithm that I described here. And as long as n is greater than 0, we divide by 2. So if we went 6. Okay, so n is 6. 6 is greater than 0, so since that's true, it's going to do whatever's in here. So it's going to set a variable and go n modulo 2, and that will give you no remainder, right? And then we're going to take remainders dot append whatever this remainder is. So since this has a modulo of 0, we're going to append remainders with 0. Then it's going to say whatever n is left as. So in this case, we said n mod 2. We didn't change n, but n is still 6 here. And then we're going to divide this by 2. And we're saying that n, this is just a shortened way of saying n equals n divided by 2 to create a new n. And this becomes 3. And then it repeats back up to the while loop, and it says while 3 is greater than 0. Okay, so 3 is greater than 0, that's true, so it's going to do it again. And it's going to go 3 mod 2 has a value of 1, and so it's going to append this list with a 1. So now there's a 0 and a 1. And it gets down here, and it goes 3 divided by 2 is 1. So now n is 1, and it goes back up here, and it says while n is greater than 0, well, 1 is greater than 0, so it's going to do it one more time, and it goes through and gets another 1. So now I have 0, 1, 1 would be this remainders list. So then the sequence is then reversed from 0, 1, 1 to 1, 1, 0, and then we print it out, and then you'll see it here, if that makes sense. And just to see how this works on the inside, I can actually print like n equals, and then I'll just print out n, and then I'll also do a separate statement where I say print remainders. Oops, not in quotes though. Let's print remainders. So what I want to see is what is the value of n and what's in our list every time. And then every time it goes through the loop, it'll print this out again. So we'll get multiple of these, and then we'll get the final answer here. Okay, and I'll even denote that with a final answer thing here. So let's see what that looks like. N equals 3, it has a 0. N equals 1, it has a 1. N equals 0, it has another 1. And then the final answer is 1, 1, 0 after it reverses. So that is how a for loop works. And at least just one example. And you'll notice it's possible to put comments after your code. That's something you can see. Inline comments are used commonly to not just using them in blocks like this. There's other ways to do this as well, where you don't have to put one of these signs in front of everything, but we'll get to that later. So notice that while the while loop is in a condition to continue looping, it evaluates to true, then the body is executed, and then another evaluation follows, and so on until the condition evaluates to false. So when that happens, the loop exits immediately and doesn't continue with the rest of the body. If the loop never evaluates to false and it just is true forever, like if I had, while n is not equal to whatever, some string, hello, then it would just run through this loop forever, and our code would never stop, and that's called an infinite loop. Infinite loops are used whenever you're like polling a network device, for example. You can ask a socket whether there's any data, and then you can do something with it if there is. And then you'll need to like sleep for a little while. Sleeping is like how you pause code, kind of. And then you ask the socket again over and over and over, and it never stops. So when you think of like monitoring tools inside of them in the code are just using while loops and evaluating some expression. While true, okay, check if this is there. Like, can I connect? Yes. Okay. Repeat. Okay, well, it's still true. Can I connect? That's true. And it will just keep going and keep going and keep going until it can't connect. And then it will cancel. Will cancel. It will break out of that while loop and then something else. And then you can program it like send this email or change this color on the dashboard from green to red and flash the screen or whatever you need to do. And so all these monitoring alerts and things like that are also using loops, probably while loops especially. Um, Having the ability to loop over a condition or to loop indefinitely is the reason why the for loop is not enough and why there is a while loop. Um, so let's take a previous example that I did and convert it to a while loop, and you'll see what this might look like. So I made a little rock band earlier, and I had Nick, I think we had Rick, and I had Roger and Sydney. And then I also had their ages, which were 23, 24, 26, and 31, something like that. And this is not what I wanted. That's what I wanted. Okay, so if I could say position equals 0, and then, why is this red? Where are you? It's not closed because there's not a comma here. Doop. All right, so position is 0, and then I'm going to say here, I'm going to say while position is greater than the length of the people sequence, then person equals people position, and I'm going to spell it correctly, position, and age equals ages position, and then I'm going to print the person and age, and then I'm going to plus equals, which is increment, or add 1 to my position number. Now the length is 4, right? So the position is 0 right now. So since position is 0 and it's less than the length of people, which is 4, then it's going to say this is true, so I'm going to do these things. And then I'm going to increment by 1. 1 is still less than 4. This is true. I'm going to go do these things. Increment by 1. 2 is less than 4. I'm going to increment. 3 is less than 4. I'm going to increment. 4 is not less than 4, false, and then it's going to break out of this while loop and then stop. So if I look at, what is this? So it still does the same thing, but you'll see that I kind of have to write extra code to do that, right? Everything can be done in a for loop, can also be done in a while loop. And even though there is a bit of, like I was saying, boilerplate you have to go through to achieve the same result, the opposite is also true. So unless you have a reason to do so, you should use the right tool for the job. 99% of the time, you'll probably be fine. So yeah, so the for loop, you need to iterate over iterable objects, and a while loop is when you need to loop according to a condition being true or false or satisfied or not. If you can just keep those two separate with those two different purposes, then hopefully you'll never choose the wrong looping construct. So there you go. There's the while loop.